In this video, I will talk about the process of discharging the capacitor. So what I did in my previous video, I was able to charge the capacitor, and I know the physics that that resulted in the capacitor being fully charged and no current flowing in the circuit. Now what I'm gonna do, I'm gonna move this wire here so that the capacitor is no longer connected to the battery, but the capacitor will be connected to the bulb. So I can see that the charges are less and less here on both plates, and the bulb is becoming less bright as the time goes by, and I can see that now the current is gone. There is no current flowing in this circuit, and now there is absolutely no charge on the capacitor. So the physics behind this, similarly to what I had before, now I have the capacitor. It is charged, and this is my wire. This is the thick part of the wire, and I have the thin part, and you can think of this thin part over here as a model, as a simple model for the bulb. Now it could be that this is a simple model for a resistor. Okay, whether you have a resistor or a bulb, it doesn't really make a tremendous difference. Really, the biggest difference is that if you have a bulb, you can actually see the effect of the current decreasing. Now, as I said before, once you make the connection, it will take 10 on the order of nanoseconds, 10 to minus 9 seconds, for the distribution of the surface charges. So it will take roughly 10 to minus 9 seconds for the distribution of the surface charges, and it will take, okay, this is one time scale, and it will take a few seconds for you to see the current going to zero, the electron current to be zero. Now what happens? So as I have here more positive charges, since those are closer to the positively charged plate of the capacitor, the electric field here will point up, here it will point to the right, here it will point down. Inside the bulb, I'm gonna have a greater electric field, consistent with a bigger difference of the surface charges. Electric field goes left, and here it goes up. Now because I know that the electric force that is acting on the negative charge, I know that the electric force QE, Q is a negative number. When I think of electrons moving, the electric force will point in opposite direction here. So my electron current, the electron current that is flowing in the circuit, my electrons are gonna move in this direction, opposite to the direction of the electric field. So this shows me how electrons will move. This is the direction of the electron current. Now, if electrons are living away from the negative plate, so let's say I take this electron and I move it here, it goes through the light bulb or the resistor, whatever this is, and now they keep going. The electrons keep going around the circuit until they reach the positively charged plate of the capacitor. When that happens, I have just removed one electron from here and moved it to the positively charged plate of the capacitor through the bulb, and this allows me essentially to say that now I have been able to neutralize that excess charge. And then as the time goes by, I take another electron and move it through the wire and the bulb, and it goes to the other side, and it counteracts, it neutralizes that one, and this one also, and then this one takes care of that, and this takes care of that. And if you wait for a few seconds, all of them are gonna be completely gone, and they will be able to completely neutralize the other plate of the capacitor. But now I have nothing I have nothing on this plate of the capacitor as well, and this means that I no longer have any surface charges distributed on the circuit, which gives me which gives me no electric field. There is nothing to create that electric field. So, and this is when your current is exactly 0. So this is no surface charges anywhere, no electric field. And it does take a few seconds, depending on what you have connected to the resistor. It will take a few seconds to see that current to go to 0. If you have something else connected to your capacitor, it may take a few minutes. And you can actually control that. You do actually control how long it will take for the capacitor to be fully discharged. But at the end of the day, the important thing to remember is that there are two time scales. Nanoseconds, certainly nanoseconds for the distribution of the surface charges to give you that current, and a few seconds, a few minutes, and so on to until you get the current to be exactly 0.